Good morning and good afternoon. My name is Norman Clark. I'm a field applications engineer at Electro Industries, and today I will be providing a general overview of the Shark 250 meter using the COM-EXT software. The things that we'll be discussing during this webinar will be communications in the COM-EXT, the V-switch, polling screens, uh, phasor diagram, meter profile, and web page and web server of the communicator. Note, I will also be connecting to a Shark 250 meter in our lab and discussing the individual topics. I will probably be going back and forth between the slides and the communicator, so hopefully it won't be much of an interruption. So there are 6 ways of communicating with the Shark 250 meter. Um, the first one is the USB on the front panel. The second is the 10/100 Ethernet, which is the optional board that you can purchase. It's the INP 100S card. And the third is the RS-45 uh, uh, on the rear of the meter. So when you first connect to the meter with the USB 485 connection, I should say the USB to USB connection, you will need to purchase a USB cable, which is the USB mini B plug. We call it the USB type A to type USB mini B plug part number CAB 26522, which you can purchase online at electroind.com/shop. And so once the USB A to USB mini cable is connected, you will also need to have a computer and a laptop computer connected from the USB port to the mini USB port on the front panel of the Shark 250. And once you make that connection to both, you will then be issued a COM port, and this can be observed through the device manager in the Windows screen. So the next option is the Shark 250 Ethernet connection. This is basically a laptop computer. You'll need USB to Ethernet converter and a Ethernet patch cable. And of course, the Ethernet option allows you to have 12 Modbus simultaneous connections, TCP connections to the meter. And the default IP address for the Shark 250 is 10.0.0.2. And this is a demonstration of the Ethernet cable connection to the rear of the meter, the Shark 250 meter. Next, we have the Shark 250 RS-485 connection. And this comes with a built-in RS-485 port to the rear of the meter, as we took a peek earlier. You'll need a USB to 485 cable to connect to this meter. Typically, you can purchase this online from electroind.com, products, and so on. And this is a 6-foot cable. Again, you can purchase this online. You'll also need an additional driver, USB to RS-485 driver. Also note, going back to what I said previously, the USB to USB connection with the mini plug does not require a driver. A Windows driver is sufficient to get you started. With the USB to 485 driver connection, you will need to download that from the ElectroInd website. So the USB cable is a 3-conductor cable, and it's connected as follows. You have the orange, which is a plus connection. So when you look at the wiring, you'll see orange, yellow, and black, and that's the side that will be connecting to the meter. Again, the orange is a black connection, the yellow is a minus, and black is the shield. And this is what it would look like after you've made your connection to the back of the meter on the 485 port. And this is the cable that you would purchase online. The USB 485 connection is also connected to your computer end, and a port will be assigned once you make the connection. So again, if you look at your device manager, you'll see COM port assigned for that USB 485 cable connection. In this case, it's COM port 8. So we basically got the preliminary information on getting started with the communications. So now we would need the software. And this entails going to the website and downloading the free software that it's called Communicator EXT software. And the link is electroind.com/downloads/software downloads. And once you have that software in place, you do the install, you're pretty much ready to go and connect to a meter and start doing your programming, viewing, and so on. And so in this particular case, we've gone through the USB, mini USB connection, the USB to RS485 and Ethernet. And I personally prefer to go to Ethernet because it's the simplest setup. When you do this, choose this option, that's assuming that you have the Ethernet card purchased. You will need to set up your laptop computer to make sure it has the same address as the meter. Note the meter does default to IP-Edge 10.0.0.2, subnet mask 255.255.255.0 Class C address, and you would have to set up something similar to your machine on your laptop computer, which would be on the same network, except the host address at the end would be anything other than .2. So let's launch Communicator EXT. So I'm going to jump out and let's take a look at what the communicator will look like once we connect to it. So we'll click on the connect button, and we'll notice a pop-up screen that has serial and Ethernet. In this case, we're going to choose to do the Ethernet, or network connection, I should say. If we chose the serial connection, we would have used one of the USB connections that we talked about before, which is USB to USB or USB to 485. Again, in this case, I prefer to use the Ethernet option or network option and connect to the meter. So this type of connection, you will need, again, the address of the meter, which is defaults at 10.0.0.2, and that would go into the host field. The network port number remains the same. That's a default Modbus TCP port number, 502. And note this is a Modbus meter, so naturally 502 is the port number. The Modbus TCP option would be chosen, and you're pretty much ready to go. It's at this point we can click OK. The meter that we'll be talking with in our lab is a 172.20.167.187 address. So it looks like it's having trouble connecting. I'll try and see if I can do that again. Let's see what happens. Okay, let's see. Let's try that once again. Maybe 3 is the charm. There we go. So when you first connect to the meter, you see the device status box. And in that window, you will be able to see the device name, the meter name, device type, it's a Shark 250, the serial number. And in the other half of the screen, you'll see the firmware version. That is the boot, firmware version 1 in this case, run version 2, ASIC version 3, state. These switches very important. We'll touch on that briefly as we go further in. The assembly late, date of manufacturer, and temperature, and what other option boards are installed. So we know the network card was one of the option boards we talked about. And then there's also in this meter a KYZ board, which is option 2. And we'll talk about those as we go further along. The first part of this connection is, I think we're going to talk about the V switch. So we'll go to the tool screen and the V switch. The V switch is basically gives you the option of installing certain keys that allows us to upgrade meter memory, additional memory for the extensive data logging, which we'll talk about a little bit earlier. The option V switch keys are the range from V2 to V4. And so this also gives you ability to look at trending, additional trending, limit alarms, IO changes, and other things such as waveforms. Um, um, I think pretty much that's as far as the limitations of what we have. So what you would do is you would click on that box, and assuming that you contacted somebody from Electro Industries as support or anyone in sales, they can help you get this started. So they would basically assign you once the order is placed for the V switch upgrade, you would be issued a key, a special key, and you would enter that into this field and click update, and that would allow you to get to the version of the V switch version, which again could be anyone from V2 to V4 for the Shark 250, and that would allow you to see some of the options that you wanted. And that concludes module 1, which basically talks about connecting to the meter and the switch option. So connecting to the meter, once we are here, we've connected to the meter, we have a few menu choices to pull down from. I won't go into everything on day one, all the menus, but I'll touch on a few things like the real-time polling, which is very important. Um, we'll also talk about tools, which will give us real-time, I should say, the programming information. And those are the basic things that we'll talk about today. So let's get started. So I'll look at the real-time poll, and we'll look at the real-time readings. So the real-time readings, we'll click over, move over to instantaneous polling. So instantaneous polling, what you see are the real-time, the meters updating, as you can see, instantaneously on what we call real-time. And what you can see is the voltage on the left side, VAN, VBN, VCN, all voltage A to neutral, B to neutral, C to neutral, phase-to-phase voltage, A to B, B to C, C to A, and your instantaneous currents, IA, IB, IC, and the neutral current. So you can see there's some imbalances here that we're seeing some current flowing on the neutral, but this is very normal in a lot of cases. So in the other column here, we see a max min values. Real power is demonstrated in the center of the screen, where you can see real-time megawatts in this case, because it's 4,141K or 4.1 megawatt, and that would be the instantaneous demand value that you're seeing at that time. You also see average values and min and max values in the real power screen. Additional to that, on the screen you see real power VARs, and again this is 1 second average and min max values, and it's updating as we speak. The next column or window is the apparent power, and we can see all of that. With all this information, you have enough to determine power factor, but it's not, although it's not displayed here, we can see that in other windows. You also have drop downs, voltage A, B, and C, I, A, B, and C, and as you can see, it changes colors to represent uh, um, um, each measurement for voltage, or I should say each quantity for volts and amps. So we'll close this out, and we'll take a look at the next screen, which is real-time pole min and max values. So here we can see man and min readings from this screen. Uh, VAN, VBN, these are maximum values over the period that, over a certain period that that the file is was created for. So we have volts, AN, VBN, VCN, and phase-to-phase voltage, average demand, maximum three-phase watts demand. So that's the peak value that occurred during this period. There's a date and time associated with that, and the, and um, and the time. There are all the other information that you can see with this frequency, quadrant, individual quadrant. So you get a large amount of information. If I just expand this further, this almost seems like it goes on indefinitely. But it's just a large volume of data that you get with this min and max screen. So I think we're going to limit this part of the discussion to just these two for now, and we're going to take a look at the revenue and energy, um, revenue and energy screen. So the revenue and energy screen, we can take a look at the power and demand average, I should say power, demand, and energy screen. So what we're looking at is, again, a lot of the same information, but broken down different ways. The total VA is reported here, total watts, total VARs. So if you were looking for power factor on one of your polling screens, you will find it here. You'll see a min and max values reported here as well. Also on this screen, we actually see what's on the registers of being, what, if you want to take a screenshot of what the energy readings or register readings on the display of the meter, you would go to this screen. And this is one screen that you can look at to get that information. It also provides the demand window. This is set for block demand. That means energy stored in 15-minute blocks. This is 15 minutes as opposed to rolling demand. Those are the two formats for demand, rolling and block. And depending on what your perspective or who you are, utilities like to use rolling demand as a selection, and some other customers might want to use block. So it varies on your choices, but this is what screen that you will get from the power, demand, and energy screen. So let's go continue here with the demand. So this is the demand or average demand screen, and this is basically breaking down again with the quadrants, 1 and 4 for delivered watts, or 2 and 3 for received watts, quadrants 1 and 2 for VARs delivered, and quadrants 3 and 4 for VARs received, and your total VA. Again, this is the average information for that period, and it's shown in the screen. So we'll look at what we call the demand grid. And the demand grid shows a lot of, again, a lot of the information. This is interval end at 4:23 up until 4:30. So this is showing all the data posted up until that time. And again, it's similar to what we saw before. but it would be more current than what you would than what you saw in the previous screen. Then you will find the energy grid. So here you find, as we saw previously, uh, energy readings on the display. So these are if the meter was programmed for compensation, we were compensating for line losses or transmission line losses or things like that, uh, you will see the uncompensated value here, and then the compensated. In this particular case, they're pretty much identical, so it tells me that meter was not adjusted for compensation. This column here is called the energy in the interval, the amount of energy that's stored. Um, it's telling you that's what the amount of energy that's stored for per interval. So if a meter is 15 intervals, that's 4 intervals per hour, and this value, this would be 4 times that value. And that's if I looked at 1035 and went back and took a look at multiplied it times 4, I would see approximately 4 megawatts in the polling. So it's about 4 megawatts there. But basically, the energy grid is just another way of viewing, making sure you have all your energy values. Energy in interval pulses is another way of the meter recording pulses internally. It has an internal recorder where it stores this information, and you'll see it recorded in pulse value, not in an energy value. So everything here pretty much replicates, I should say, similar information that we saw previously, except these are all energy values. These are not instantaneous values. It's this energy for a interval period. So time of use is where we are now. So time of use um, gives us the ability to set up the meter for time of use, or we call it time of demand, or TOD, or there are lots of different ways, names or terminology that people use, but basically these are primarily set up for customers that use or are involved or signed up for this program, usually with a utility, where they would get a certain rate based on the time of their consumption. And so this allows the meter to capture that information. So here it's typically set up by seasons, prior billing information, current seasons, and so on. So this is stored in the meter, and the meter would automatically save the information for retrieval at some point. If you look at the status, this is an area where if we're talking about once we set those up, we can see the various seasons that we're looking for if you're looking for billing period information. Self-read status typically means that the meter does what we call an automatic reset. If you set the frequency of how you want it to reset, it will do an automatic reset. For instance, if you wanted to reset once a month at midnight, at the end of the month, you wanted to bill a customer, you would set this up for self-read at the end of the month. And that is tied to a calendar in the system where you would set your date and time for that period, and the meter would execute the reset. So polling pulse accumulators. Pulse accumulators are, in this particular case, we see there's an option board that the meter has the ability to take in pulse, also ability to put out pulses. And so if we had a module or anything, that additional device that we added on, this would be a card, an option card. We would install it, and we could take in pulses from a water meter or gas meter, and it would be accumulated into these registers. So that's what the pulse accumulators are. And you would label the quantity that you're bringing in. If it's a water meter on the west side of a building, you could name it such with a name similar related to something like that. But yeah, so this is the option board that brings in all the pulse uh, data externally. And again, this is something that you would purchase separately and add it and install in the meter. It's just a card that's installed, and it's a slot, and the meter has two slots available. And so currently this particular meter has an Ethernet board, and you have one other option, and we saw that when we first connected. It looks like a KYZ board. So those are the options. Next, we have the pulse aggregators, and this meter has the ability to aggregate internally different quantities that you want from different sources. So if you're aggregating energy, you want to totalize energy from two different sources onto one channel, the meter allows you to do that. There are four options or four aggregators you can build, and you can generate reports and view that information as it was one quantity. So again, it aggregates all the individual input points, and it allows you to view that information. And that's conclusion of module 2, which basically covers the polling, um, the polling features that we currently have here. We did real-time polling, revenue, energy, and demand polling. Power quality is something that we're going to reserve for the day 2, but it is quite extensive, and so we considered that advanced version of this presentation. So we'll set that for next tomorrow, and that should we should go in further in depth with that discussion. So let's take a look at the tools menu. So the tools screen, we have edit current device profile, um, the change V switch, which we discussed briefly earlier. Um, uh, what other things that we can do here are we can set the device time, we can retrieve device time, we can reset the meter information. That is all the information, the log information. If you want to clear everything out, which we don't want to, it can be very dangerous. The security, you can enable security, um, which we'll talk a little bit about tomorrow. Then the device information, the option card, meter firmware updates, you can choose from here. So if you decided you want to update a firmware, this is what you would select. Then there's the manual waveform capture test mode. If you want to test the meter, utilities normally would use this function, and you want to do presets, which is a nice feature. You can test the meter, put it in test mode after you finish calibrating the meter, testing the meter. You want to adjust the registers as if the meter was never removed from service. The network card status, this shows you basically it's some status information that everything is working properly. The MAC address and so on is also provided here. So, but basically the tools is allows you to do a lot of the fine tuning and when setting up your meter, and additional external testing and so on, as we mentioned. Um, the current device profile, probably the most important area that we'll want to discuss, and we'll go right into that discussion. So we'll retrieve the meter programming settings from the device, and initially once you connect, you will see all the parameters that we need to set up for the meter, which are CT, PT compensation, time settings, system settings, communications. Uh, you can configure the serial in that communication settings, the DNP settings, um, general settings on the DNP. So all this that falls under DNP is all the settings that once you enable it, they're going to be impacted by the changes that you make in the setting. The display area basically sets up the display for the meter how you want it viewed by the customer or whoever is looking at this. You could set it to auto scroll, or you could set it to not scroll. You could set it for all your phases, A, B, and C displayed, or at the individual A and B or A, whichever you wanted. If you wanted to just have it be observed as a voltmeter, you can just set it up as a voltmeter or current meter by unchecking these. So basically, you have a few choices you want. Depending on what you want to view, you would go ahead and select those. You want your current auto scale on or off, load bus bar, use a custom configuration, which you can choose, and so on. So let's continue to go down briefly. We'll talk about the revenue and energy to scale, scaling. We could talk about the power energy labeling and aggregators that we mentioned earlier, um, and so on. But before we get into that, let's go at the beginning and start about our CTPT compensation. So the CTPT compensation is very important. We need to put in when you program the meter, you need to have firstly a one line or some kind of a diagram showing how the metering is going to be configured. You reference that to enter this information. You would pull that information. So in this particular case, from the drawing, I saw these are 500 to 5 CTs. It's 14 kV to 120 type PTs, and then you would determine if it's a line to line, neutral type connection. So we would need to go and determine whether it's a 3 element, a 2.5 element, or a 2 CT delta. So a 3 element meter configuration requires 3 line to neutral voltages and 3 phase currents to measure 3 phase power accurately. You would choose a 2.5 element configuration where it's we call a 2.5 element Y, where the connections are made with 2 PTs connected line to neutral. Although it's very rare, we do find that there are some existing out in the field that you will have to make that choice, a 2.5 element, and it's a huge difference from a 2 element. Some people think you could use a delta connection for a 2.5 element Y, and that would not work out because primarily the phasing and relationship between the voltage and the current vectors would be different in a delta connection. Then we'll go down to the 2 CT delta, which requires 2 line-to-line voltages, typically VA to B, VC to B on a diagram, with B as the reference, and 2 phase currents, and we usually look at that as IA and IC. IA coupled with VCB and IA coupled with VAB and IC coupled with VCB. And so here you see the full range, voltage, full scale ranges, 14,400, current 500 amps, 500 to 5, the total power. The phase power is 41,156 in this case, K, and then the total power would be 3 times that at 12,470. And we see total demand distortion setting, which is 5 amps, which is a reference for total harmonics demand distortion. Okay, and then let's go down to the time settings. So we use the time settings to set up for standard time or daylight savings, the zone descriptor, what area of the world you're located in where you need to set your reference time, and the clock synchronization method. So in this case, it's set for disabled, but this meter offers a line sync and NTP option, which is great if you have an NTP clock that you can sync to, which has a satellite GPS connection. You would want to use that. That's the best option that you have to sync the time with this meter. Or you could choose a line sync, which is a 60 hertz frequency to sync the line sync. The problem with line sync and the line sync choice is that, and here, before I get into that, you have option of 50 hertz, which is different parts of the world, South America to Europe, where you can change different frequencies. But the line sync allows you to sync to that frequency while the unit is online, while the meter is online. If there is a power outage and you actually lose, if this is the meter is powered up from the phases and you actually lose power, the meter will switch automatic to its internal clock. So either way, the meter continues to maintain the time. So we'll go to the system settings next, and that area, you can set up the meter designation. That you assign a meter name, and this meter name would be anything for if it's a unique situation. You want to specify what that designation name is. By the way, that name, if you're a utility and using MV90, that would be your device ID name in MV90. And then there's also some area for scratchpad work where you can write in some notes, anything you want the meter to display when you first connect to it. The next option then you have are the test mode settings. So the test mode can be set up to 10 hours. And if you look on this screen, you can have this. Right now, if I wanted to put that for 600 minutes, that's roughly 10 hours I can have. And basically the test mode allows you to take a meter out of service, perform a test to check for accuracy, and we call it calibration, to make sure that the meter is within its recommended or the accuracy level where it should be. If it's a 0.2 meter classification, it has to meet within, it has to test within that classification. So here, when you take the meter out of service, you test the meter, you inject voltage and current into the meter, and you apply it to a standard, and you make some comparisons to see how the percentage registration, to see how far it is off. I'm kind of explaining calibration in a quick couple sentences, but basically, when you put the meter in test mode, it allows you to test the meter, and the longer you have, the window you have to test, the more time you'll have to test the meter without the meter kicking out of the test mode and interrupting your test process. So that's very important. That 10 hours is a very good amount of time. Some people take an hour, some people take 3 hours, 4 hours to do a calibration. So you want to set that based upon how you test the meter or who is testing the meter. The vector sum is just another method of way of, vector is a phasor diagram, basically calculation method for VA and H, or arithmetic sum calculation. So you have a choice. You typically leave it at the default, and it doesn't affect the computation other than using any of those methods. You won't see anything in your measurement process. The next area is the communications. Communications allows you to set up the ports, just like we talked about briefly early on, the COM1 USB port connection and COM2 485 connection. So those are what we would use if we were connecting to the meter over the optical port. We said USB, and I should say optical. Over the USB connection in the front panel, it would be COM1, and in this meter, although your laptop that you're setting up the meter to connect to this port would be assigned to COM8, as we saw before. So COM8 is your going out of your laptop, connecting to this meter, which is represented here as COM1. You would need to connect at the protocol speed, at protocol of, I should say, Modbus ASCII, and the baud rate of 57600. If you don't have that setting, you will not be able to connect up to the meter using the USB connection. The 485 to the rear of the meter is a Modbus RTU protocol, and the baud rate again is 576. So when you set up your connection, you would set it at Modbus RTU and 57600. We talked a little bit briefly about the DNP3. You have to enable DNP. So this is an area where you would go in and retrieve your SCADA information. Typically, uh, the DNP setup, uh, if it's something that you would be turning on, it usually is driven by your SCADA or RTU folks would basically tell you you need to have this enabled so they could pull DNP from an RTU. So this is the area where you would go in and turn that on. So as you go in and select all of these are all parameters associated with DNP setup. This in itself is a lengthy presentation, so it could be reserved for another time with a total different discussion. We'll just jump into the revenue and energy settings real quick. We kind of skimmed through it previously before, but we'll go over it again. So this is where you set up the number of digits that you want displayed on the register, the decimal resolution, how many digits of resolution, scaling, if you want kW, if the meter's in kW load or megawatt load, or if it's just watts. These are what you would choose from the drop down. And you generally set these all at the same. It's up to you, but basically, when I set these up, personally, I set them all at the same resolution, 8 digits, let's say 3 decimal places, and this is what it would look on the value. So there's 8 digits overall in your 3 decimal places, and it's kW. Here, if you chose M, it would be M megawatts, and so on. But this is where you would do your setting for register displaying energy scaling or register on the front of the meter, the number of digits you want to see. Power demand for display purposes. This is an area where you would set your demand to, you want it to automatically scale for display purposes. So it's pretty self-explanatory. And demand averaging is, I mentioned this briefly, between 2 types of demand averaging. There's block averaging and rolling. And block is basically if you were to store the energies, the average energy stored in over a certain period. In this particular case, it would be 15 minutes. So whatever energy stored in that 15 minutes, the meter would collect that bundle of energy, store it in the 15 minutes, and that's considered a block. If you're storing energy in a rolling, rolling or sliding window is a term that people use a lot. It's you would basically have data that's being sampled every particular at a particular rate. So in this particular case, we have 15-minute interval. We want, let's say, 3 sub-intervals. Let's say make that 5-minute intervals, and we want a 50-minute block or 50-minute interval. The reason why I said that, because block, typically we use a 15-minute block and try to make it equivalent to a 50-minute block, a 50-minute rolling window. So this would be an interval window of 15 minutes, and we would have 3 sliding or rolling windows or intervals, samples of data in one 15-minute interval. And in this 50-minute interval block, again, forgive me for saying block, it's a rolling. In other words, you have 3 intervals, 3 intervals that are 5-minute in size or time-wise, and they would be inserted into this, or the meter would be capturing these and sampling these. The advantage of having rolling is that that rolling method demand provides the highest demand that you could have. So one of those 3 5-minute intervals and that 3 15-minute intervals, whichever is highest, will be reported as the peak or the highest value for that 15-minute period. In a block, the block average that we talked about before, the block is just take an average number of whatever those are. So it typically is lower than what you will find for the 15-minute period than a roll-in. So utilities like to use the rolling because it produces the highest demand over 3 5-minute intervals for a 15-minute sample period. Energy scaling we talked about, so let's go to power and energy labeling. And this is just the labeling of the meter, of the phase angle directions, for the power and energy during for the meter itself. And here we have positive for quadrants 1 and 4 for what hour is delivered, and quadrants 2 and 3 for what hour is received, power hours delivered, and so on. Quadrants 1 and 2, and power factor, and then here are the labeling information. Okay, so we talked about the aggregators briefly, and this is where you would set this up. Um, the we previously mentioned this. This is a you would have your aggregators in on different options, and you would add what channels that you want selected, and you would make all your entries, select all your options, depending on what you have as an option board, and you would aggregate those points. And then produce it from this is all grayed out because I don't have the option board available turned on to make use of this. But you can, oops, I take that back. I needed to record the meter energy. There I have, I can add or subtract functions in this aggregator portion. And here you have it here, add or subtract. You could add energy values, and you have a choice of different quantities that you could pull down and aggregate onto one channel. And then you have your format of how many digits you want. Display would look like almost like a separate meter, but you're adding up all the different points from the meter internally. So this is a nice thing to have for total aggregation of different data points within the meter. Cold load pickup. This is a feature that we turn on and turn off. Basically, and this from a utility point of view, you may want this because you may want to defer or not penalize a customer shortly after power has been restored during an outage. So you want to defer a certain amount of time. Typically, industrial customers would benefit from something like this, where as power was restored, the peak wouldn't slam in the first interval, and customer would be penalized for that interval. So you would enable that. A lot of utilities defer use this option, and it varies from utility to utility how much of a period you want to defer, and we call that cold load pickup. Transformer loss compensation is something that we will get into tomorrow. It is a subject that is very important. There's obviously there's line loss compensation and transformer loss compensation. Those are the most important ones. But we'll talk about that tomorrow. Time of use, we mentioned that briefly. We could get prior billing. We could get time of use schedules, rates, and so on by enabling the time of use function. And so that's where you would enable that function. Let's look at the internal accumulators. This is an area in the meter where the pulses are being recorded internally in the meter as a separate recorder, and you can retrieve the pulse data from the meter. And that's not an optional board, that's internal to the meter, and that allows you to get that information. The next one is the optional 2 digital input pulse card. This is what we call KYZ, which is the meter itself will put out pulses to an external recorder at a pulse rate that is it's weighted that the customer can program into their recorder or their own equipment that is retrieving these pulses. So it's basically the meter is outputting pulses. In this case, it's 1.8 kWh per pulse, and this is a secondary value. In order to come up with a primary value, you would take the power ratio, which is the CTPT ratio, multiply times this, and then give that value to the customer and program it into their equipment. And this is just your labeling that you can assign for that customer. So if you wanted to give it a name or anything, you could just go ahead and choose what you want to put in that field. CTPT compensation, those are errors in the instrument transformers that we will also discuss tomorrow. And it basically, these are all driven by the transformer report. Basically, someone testing the transformer and finding these inefficiencies or I would say minor defect, which translate into requires a translation, or I should say a correction factor, and that would be inserted into this, and that's generally uh, what you would retrieve from that. As you can see, there are A, B, CT compensation, and that's for the CT, and so you would enter those values in. For PTs, you would do something very similar. You get the values and you would enter those in for A, B, C phases. Okay, power quality we'll get into a little bit tomorrow as well. This is where we set up all our thresholds for power quality. And again, this is something that we'll talk about tomorrow, but this is a very important feature that people like about this, the meters, that it has the ability to capture or trigger certain events if you exceed any of the thresholds that you would set up in this area. Your waveform, which is another thing in this meter, it provides waveform capture, which you have the ability to capture up to 512 samples on this meter. Um, and, um, and that affects your total, your trigger size. So 512 samples, you have 2 triggers, you have pre and post trigger. And so this gives you ability to control what you are trying to capture by setting the sample rate. So this is pretty nice. There are waveforms that are generated as a result of setting these parameters. So let's go to the logs, historical logs. First, we talk about the log sizes. So this meter has 6 historical logs where you can set up the parameters as finest resolution at 1 minute intervals to 60-minute intervals. And so here are your sliders. You can specify how large you want those logs are. So depending on how much data are, let's say if you only program a historical log 1, you probably want to extend that to a larger size. If you don't want as much data on, let's say, historical log 6, you would set it for 0. If you're retrieving on log 6, and maybe I should back up a little bit. Let's make that log 3, historical log 3. You would extend that. I think you're able to make use of the historical 5 and 6 logs if you enable vSwitch higher, which gives you more memory. So I think that's why these are not coming up. But basically, this is your slider that controls how much data you want stored per log. So let's talk about the historical logs. Okay, so this meter I'll go through real quick, historical log 1, 2, 3, 4. It's pre-programmed with 1, 2, 3, 4 logs that are set up to retrieve data. So historical log 1 has volts, A to neutral, B to neutral, C to neutral, I, A, B, C, watts total, vars, frequency, and voltage. So that all that information is going to be stored in the meter. It will be stored in 50-minute blocks, and you get 22 months of data. That almost 22 months, almost 2 weeks, and so it's a lot of data you can store for log 1. So this is how this was determined by the slider that we talked about before. So log 2 is set up for energy, and this is a typical log that most people use to retrieve meter data, so interval data. So in this case, this meter is programming scaled energy in an interval, delivered, which is watt hours delivered, var hours received, I should say watt hours received, var hours delivered, var hours received. And that's a 4-channel configuration. and that was selected from your energy screen. So this is your menu of choices that you could pull from what you're trying to bring in. Scaled energy, this is a subgroup of what you're looking at that will bring in the scale energy values. Uh, Scale energy in an interval, scale energy in an interval pulses. Let me just briefly go over what these are. So scale energy is basically the registers that are on the display of the meter that are brought into a log file. So every time you read the meter, you take a snapshot of a reading, it comes in. It basically is a snapshot of the reading on the display, stores that into a location at a particular time. The next time you read it again, let's say you read the meter at 11 o'clock, it would post a reading for that. So this is a good way of actually capturing readings in the meter. That, let's say you wanted a reading last month at 11 o'clock at night or some event, you can go back and retrieve the historical log set for scaled energy and bring that information back. Scale energy in an interval is really the energy that's stored in that meter for that interval. So we have 15-minute blocks here, and it's calculating the total energy from that for that period. This is different than what we're talking about scaled energy, which is actually the reading itself for that time, for that interval ending. So scale energy in an interval is the total energy. And scale energy in an interval pulses are the actual pulses that are calculated in the meter that for that period. So there's a pulse weighted a value that's assigned to that pulse, which would, if you multiply, let's say if it was 1.8 kWh per pulse, and you had 100 pulses, that's 1,800 watt hours. That's what you would record for that 1,800. I should say 1,800 kilowatt hours for that pulse, for that 50-minute interval. So that's the difference. Scale energy in interval pulses is a weighted value, which is basically pulses coming into that interval, and there's a multiplier assigned to that. And I could go through all the others, but it's basically a similar configuration, similar meaning for each one. In this particular log 2, we chose log 2 to be scale energy. But you have a choice of many options to choose from. In the screen also, you see you have your max and min. You could also program with your voltage and current. You have an enormous amount of information that you could capture. You have average demand values, and a lot of information again you can store in the meter on those in your programming. Cumulative demand, you have watts delivered, watts received. Those are your 4 choices. And timestamp, I've never used that one, but you could also profile or capture demand last reset times and store that in the meter. As we scroll down, we'll get down to the options card. Let's go to the option card 1. We talked about the IP100, it's a network card, and that is the allows you to set up the network communications in the meter. So here is this is the IP subnet mask. It's pretty self-explanatory. So let's go down to the services and security. And in this area, we talk about enabling the web server. The meter comes with a built-in web server, and so you can enable that so you can use any browser. In this case, port 80 is chosen. A lot of the companies might block port 80, so this gives you the ability to change that browser port number to anything other than port 80. So you have that choice. The Modbus TCP server, you want to enable that so you can do Modbus polling. And again, the default port number for Modbus is TCP port number is 502, although you have the ability to change that to any other port number, especially if you're doing port forwarding. It's something that you want to be able to change those port numbers. The next is Enable email notification. You want to enable that if you want to make use of that feature, which I'll discuss on the second day of the presentation. And so here we have, this is where you enable DNP support. Once you enable that, you could take advantage of all the different settings that we've talked about up here, and you can make changes. So that's a separate discussion in itself and very lengthy. Option 2, digital input pulse card. We talked about setting up the meter to have the ability to receive pulses from a water meter or gas meter. This is where you would set that up. And you can set it to trigger on opening, closing settings, high-speed settings, and so on. Accumulator is you may want that turned on if you want to capture all the input coming in. If you want just status information, you would just turn that on. But this is very important if you are taking impulses from another source. And again, we talk about gas and water meter, but that's typical. But it could be something else. It could be a temperature device that's pulsing. You want to record it, what that might mean. But a number of things it will take, and it's two-wire contact. So it really doesn't require much to make that connection. I think with that, that concludes this area. So we'll close that session and we'll go back to the main menu. Just a quick look, we'll just discuss real briefly phasor diagram. I know we'll talk about this tomorrow, but I think this is one of the most important screens to look at. It's a great tool to troubleshoot, verify wiring, and just gives people confidence that the wiring was installed properly. So that basically, this is an ABC rotation, A, B, and C, a 3-element Y. It gives you a lot, shows you the amplitude, the magnitudes of the voltage, current, and the phase angle and on all 3 phases. Total power would be the sum of all 3. So if we close that out. Next, I think we will just jump out of this real quickly, and we'll just do a connection to the web browser and make a quick connection, and then we'll call it a day. This area, I think we could close this for now. Let's do that. I want my IP address. So let's close this, cancel. Let's bring up our browser. So the browser, here we are, and we open up the browser. Basically, I entered in the IP address of the URL field, and immediately I made a connection to it. It's very responsive. It's a good way to have a connection to the meter at your desk without, as long as it's on the network and you have right or access to it, you can bring up all the information. It's a read-only screen. Basically, you can see all your voltage and current and phases and different things, power quality, all the different things that you would see if you were connected using the communicator software. So if someone wanted access to the meter it was on the network, you may want to just give them the IP address. Someone within your company is someone that's allowed to do that, of course. But if you're on the same network, you should be able to enter in the IP address and view that information. As we go along, we can look at also the meter information that you can look at, the information that you can get from this, the browser, the meter designation, which is the same name that we saw, the firmware version, how it's hooked up, how it's wired up, 505, 1440, 14400, 120, 3-element Y condition, network card, and firmware vision, so on. And this, again, this is something I will get into tomorrow, but basically everything that you need to really know for most people voltage, current, information on the meter, and if you know, email notification and things like that. We'll go over that tomorrow. But this section here will you'll need password information and so on to set that up. You'll need your mail server information. You need a lot of information to get that going. But I wouldn't say a lot, but important things like your mail server and password and access and so on. But that's a different discussion, and we could talk about that tomorrow. And I think, having said that, we've concluded everything that I think an overview, a general overview, can get you with the Shark 250 series meter and the communicator. And so I hope you enjoyed the session, and I thank you for participating, and we're open for questions at this point. So please send in your questions. Thank you, and have a good day.